Hello, Physics 30s. Mr. Thompson here again. All right, what we're doing is looking on page 76 of the workbook. This corresponds, of course, with chapter 13 on EMR. Looking at light as a wave or particle. Throughout history, the nature of light has been debated. Many scientists, such as Newton, thought light was composed of particles, while other scientists, such as Huygens, were convinced that light was a wave. We'll now investigate the many properties of light that were well known in the times of classical physics, which was before the 20th century. Many of these properties gave convincing evidence that light behaved like a wave. All right, reflection of light in plane mirrors. Let's look at the law of reflection. Okay, so in the law of reflection, the angle of incidence equals the angle of reflection. So shown as theta I equals theta R. Here's a diagram showing a reflective surface, the mirror here. You have a ray coming in called the incident ray and the ray bouncing off of the mirror called the reflected ray. Notice the imaginary line that's shown here. It's perpendicular to the surface. It's called a normal line. In this case here, we always measure our incident and reflected angles from the normal, or based on the normal, okay, with respect to the normal. Now, both particles and waves demonstrate reflection. Images in a plane mirror. So consider how we see the image of an object. The image is located where the reflected rays appear to converge. So notice these reflected rays here, they appear to converge back here towards where that image is. Because the light's coming in this way, these are the reflected rays off of the mirror. Okay? The eye cannot tell the rays have been reflected, so they assume that they travel in straight lines, and that's why you perceive the object to be inside the mirror, like behind it. But light doesn't truly come from there, it reflects off of the surface. And so characteristics of the image, same size as the object, vertically upright, but laterally inverted. That means horizontally flipped. Okay? And of course, virtual, not real. The image is located at the same distance from the mirror as the object. Okay, let's try some practice questions. It says if the angle of the incident ray is 38 degrees with respect to the mirror surface, then what is the angle of reflection? Okay, so just to draw a quick diagram showing this. There is my surface, here is my perpendicular, my normal line. Now it says it's 38 degrees with respect to the mirror surface, so 38 degrees would be something like this. Okay. Here's 38, it's way off there, but we'll try and do that. And then of course 38 degrees coming off. Incident ray coming in, 38 degrees here, and 38 degrees here for that reflected ray. Now it says, what is the angle of reflection? Well, this is the incident angle, and this is the reflected angle. So the incident angle is the same as the reflected angle. The reflected angle is complementary to the 38 degrees. And so theta r must be 52 degrees, making 52 and 38, making a right angle, which is what the normal is, okay, to the surface. Take a look at question number 2. For the mirror shown, break the angle of reflection off of mirror B. I'll try this one just right on the paper here. 24 degrees here. I'll try and set this one up and try and move around this. Let's make it a little bit steeper there, why not? So it actually fits on the diagram. Obviously the diagram is not to scale. Okay, and then some kind of normal line here. Now we've got everything we need. Okay. Though it may not be to scale, the mathematics should work out just fine. Okay. 24 degrees here, that means this angle must be 24 degrees as well. 24 and 97, well, this forms a triangle, so we can figure out this angle, which happens to be 180. Take away 97, take away 24. Let's try it out. 59 degrees. If this is 59 degrees and the ray is moving along this fashion, then we can figure out this angle here and this angle here. Okay? So right? The incident angle here and the reflected angle. Well, if this happens to be 59, then this is 59 degrees, and the theta r has to be 31. Okay, question number 3, you can try that one if you wish. Okay, I'll move on with number 4. If light bounces off all 3 mirrors, find the angle of reflection off of mirror C. Okay, so moving around the diagram, same sort of idea. We want to try and make this work as best as possible so that we've got at least everything on the diagram. There we go. Okay, 30 degrees there makes this one to be a 30-degree angle here as well. So 30 degrees there. 61 degrees is here, and so I can go ahead and figure out this angle. 61 and that angle are supplementary, so that angle happens to be 180, take away 61, 119. Now I can figure out this third angle here. So 180, take away 119, take away 30, and I get 31 degrees. We saw that in the previous question. So this one has to be 31 degrees. Now this angle here is going to be 140. Running out of space here. This angle here can be determined because we've got 31, 140, and this angle. So 140, 31 happens to be 9 degrees, it looks like. Oh, 40, pardon me, 110, my bad. Looking at this 140 going, that's a pretty big angle. 110 and 31, so 110 plus 31, and then subtract that from 180, 39 degrees. So if that's 39 degrees, now here is my normal line. So this would be 39 degrees as well, and this is my angle of reflection from the surface, which happens to be 51 degrees. Okay, I'll stop right there. If you want to try out question number 5, please do so. The answers are down below, so let me know if you have any difficulties. Thank you.